Is there any need for pattern matching? I don't think so. I know there's a certain contingent of programmers who really like pattern matching, but and I've had an open mind for a long time about like, are we going to implement that? And I've just never really needed it. Um, I mean, pattern matching goes hand in hand with what are you matching on, right? And the answer to that is probably hierarchies of structs, usually, right? And just the thing that I find about pattern matching is it looks really nice as long as you're doing um, a small amount of code that like kind of fits on one screen and where the thing that you're doing in each match case is a small amount of code and all that. And like as your program gets bigger and more complicated, it just becomes less appealing, I think. And then also, right, so like I said, if you're doing pattern matching, you need to match on something. And what is that thing you're matching on? Well, some kind of like more error hardened version of a struct, right? It's like, you know, it's like a tagged union that the compiler understands in some way. And I don't want to do magical tagged unions like a lot of programming languages do because it's been a very successful thing that there are no magical structs, unlike C++ and all that, right? So that's been a decision that I made early on that I was like, I don't know how this is going to go. Let's see. And it's been going great. So I don't want to reverse that. So if we did a tagged union kind of a thing, it would be more like the tag is annotated so that the compiler knows what it is. And then you could do pattern matching maybe. I think there's some more constraints that you really need in order for it to be good. But the point being just like, you have to add some more compiler features besides the pattern matching itself. And then how useful is that? And the answer has been, not necessarily as useful as you would think. Are there option result types? No. No. Because here's the thing, again. Okay, sometimes features are designed for certain programming styles, and maybe you want to go back and question those programming styles, right? So for example, Java programmers have this style where you call 375 functions in sequence in order to do everything because everything's a trivial wrapper around everything else, right? And you look at a call stack in Java and it's horrific and takes 5 screens, right? And so Java programmers might think it's really important to have exceptions or something. I don't actually know if Java has exceptions. I assume it does. So that you can like pop stuff up many layers without having to manually return stuff. And it's like, but look, if you're not an idiot, instead of calling 50 functions deep, just do 2 functions. And then it's just not a big deal, right? It's like you only think that's an important feature because you've done this style of programming that needs it. But like, is that style of programming very good? And I think most other programmers not from the Java world would say, no, it's not good, right? I mean, if you remember back when like Facebook couldn't even ship a client on a phone on Android because it was like more than 2 gigabytes of, frickin' Java patches or whatever. Like, that was a long time ago at this point. Maybe that's been fixed, but so this whole, okay, so how important is it to have an option type to tell you if a return value is valid or not, right? And I would say, broadly speaking, this is an oversimplification, but broadly speaking, it's proportional to how much are you going to use that feature, right? Which means what percentage of functions are going to return something that's maybe valid or maybe a failure, right? Or, something else like not ready yet. Come, Magic 8 Ball says try again later, right? Okay. Here's the thing, though. This is one of the plagues that's been affecting programming is like a lot of students get taught in school that you have to like write all functions as though they can fail and test the success result of all functions. And of course, if you do that, you're going to go crazy, right? So here's the thing. In order to write code at high productivity, you want to design your code so that most functions cannot fail if the computer is working correctly, all right? Sometimes there are functions that can fail. For example, open a file. That can fail. There's nothing you can do about it because even if you check that the file's there, between that time and the time you go to read it, somebody could have yanked the hard drive out of the computer, right? So there are some things that necessarily can fail, but you want to minimize those. And you want to be very clear about what they are versus things that cannot fail, right? If I'm going to take, like, if I have a mesh with some number of vertices and I want to know the plane normal of every triangle in that mesh, you iterate over all the triangles, you take two vectors on each triangle, you cross product the vectors, you normalize that, you store that back in a buffer. That simply cannot fail if the buffer memory already exists, all right? So you should not write that function pretending that it could fail. So in good code, you actually don't have that much failure. Now with some exceptions, right? So in this compiler, we have a bunch of functions that can yield, and that would be a place where you might use this option type, right? We actually use a Boolean usually, but you could use it there. But the thing is, stuff that can yield is a big source of complexity in this compiler, so I want to minimize it if I can. And so, you know, that's why I don't feel like that's super important, is because you don't want it to be that everything can fail, right? That's all. Now, is it still, there's still this question of, okay, I did a good job trying to minimize failure points in my program. Are there still a lot? And the answer is maybe. Yeah, maybe. And would you benefit from an automated unwrapping thing in those cases? Maybe. I mean, it's still, I'm not totally convinced, right? Because you can always do it the C way and just return a struct with a Boolean and, you know, and the value. And then you're not pattern matching on that, but you're checking the value, the Boolean, right? In order to get the value out of the struct. And like, okay, that's not compiler enforced, but what percentage of the time is that actually going to be a problem and whatever, right? So like, you just have to look at these layers of bureaucracy that are being added to the language, and you have to ask, how useful is this really? And is it worth the weight of it being added? And what is the opportunity cost? So like, Rust has all these option types. I just learned the other day, they don't even have optional arguments or named arguments, which are tremendously more useful, right? And so they made this trade-off that I think is very questionable. Yeah. But that's very real though, is like when you decide what your feature set is, you only have a certain ability to put in features because they all interact with each other. So the complexity of the system grows super linearly with how many features are in there. And so if you put one in, there's like less space for another one, sort of. I mean, you could put super linearly more effort into working on the compiler and then manage to get them both. But it's hard. Like, it costs time, energy, money, compile time of people building their programs. Dude, I don't even remember. I guess we ran this. I guess we're going to do this. Do we have any no check-ins? I think we have successfully done this one. All right, so checking this in. That's great. So now we just have bytecode builder ones, and we could actually just flatten this out now because they're all only bytecode builder ones. The from trait kind of helps with optional arguments, but like, isn't it simpler to just let things take optional arguments? Right? Like, it's not like programming languages haven't been doing that for decades. So I'm not even saying that we won't eventually have some kind of tagged union with pattern matching. We might. It's realistic that we might add that to this language, but I'm just trying to give you an insight into my thought process about why didn't that go in first, right? And the answer is just because it doesn't seem as useful, relatively speaking, as some of these other things. And now the thing is, that's going against the right? There's like a psychological trend in programming language design always, like, oh, these pattern match tagged unions are like a modern feature, and if you don't have this, you're not one of the smart modern languages. And it's like, you got to not fall into groupthink when it comes to that. And dude, I used standard ML of New Jersey in probably 1989, so like, I had pattern matching on tagged unions in 1989. I know how it works. And yes, I was really excited about it for the first 6 weeks as a student when I was using it. And then I was like, well, all right, whatever.